For problem 89, it says a particle moves along a line, so its acceleration for time greater than or equal to 0 is given by a of t with this rule. If the particle's velocity at t equals 0 is 5, what is the velocity of the particle at t equals 3? So this problem is testing your knowledge of the relationship between velocity and acceleration. So hopefully it makes sense to get from acceleration to velocity. You'd need to do antiderivative or an integral. So let's think about what is it that we were given, what do we have, and what is it that we want. And once we frame this out, we should have a pretty good idea as to how to get what we want. So they gave you the particle's velocity at t equals 0 to be 5. So I'll just say velocity at t equals 0 is 5. And we want the velocity at 3 when t is 3. Okay. And we also know that if you want to get velocity from acceleration, you'll need to use an antiderivative or an integral. So if we take the integral of acceleration, we'll get velocity. To avoid the plus c stuff you'd get with an integral with no bounds, let's put some strategic bounds on it. So let's use 0 and 3. Now let's interpret what this would give us. Antiderivative acceleration would be velocity, so in this case it would give us the velocity of 3 take away the velocity of 0. So notice I'm setting myself up to have kind of a little bit of what I want and a little bit of what I have in the expansion here. So v of 3 is what I want to find, v of 0 is 5, and I'm going to make my calculator give me a decimal approximation for that integral right there. So oops, what am I doing? All right, so let's go ahead and type the rule in here, the acceleration rule. So x plus 3, because it's a good substitute for t plus 3, divided by the square root of that. I think I got it. Okay. All right, so now let's do math. We're going to do an integral using that rule with respect to x, and then going from 0 to 3. Right, so for the integral value, we got approximately 6.710, and then all I had to do is add 5 over, and we'd have it. And it looks like the answer is 8.